Hey friends, and welcome back to the startup. I'm your imaginary founder, Rob Barnes. Some of you know me as DevOps Rob. And if you're still here after watching all of these episodes, I've got to say I really appreciate you, and I hope you're enjoying the journey. I hope you're learning as much as I'm learning as we go through this, right? What do we have in store today? Well, great question. Today we're going to build a microservice as part of our architecture, and that microservice is going to handle cryptography operations with Vault, right? It's going to encrypt, it's going to decrypt, it's going to create transit keys, and it's going to delete transit keys, right? I'll explain a little bit about that as we move through the episode, but we're going to write this microservice, we're going to write it in Golang, right? And I think that's where we're going to draw the line for this episode. And we'll see in the next episode or a future one about actually deploying it to Kubernetes or deploying it to Nomad. I think we'll go with Kubernetes on this just to kind of show a different side of things. So yeah, let's get into it. Let's head over to our display. And I have already spun up a development environment. This time, I'll just quickly walk you through the code. We have a network as usual. But now this time, instead of Nomad, we're actually using the K8 resource, right? So it's going to deploy, using Jumppad, a Kubernetes cluster. I think by default it's one node, and we're attaching it to the network that we've created, right? And really the only other thing that we're doing is we're deploying Vault onto that cluster. I'll zoom this up a little bit. We're deploying Vault onto this cluster using a module, right? So Jumppad has the concept of modules, just like Terraform has modules where you can build these repeatable building blocks that other people can reference, whenever they're building their own modules or their own blueprint, shall I say. So essentially, we are using a module that Nick Jackson has built, which basically uses Helm to deploy Vault onto a Kubernetes cluster, right? So we give it the source of the module, which is just a GitHub repo. And then there are some variables within this module, which, there will be same defaults, but we have these variables overridden here. And I think I just grabbed this straight from Nick's example. So I think he's just done that just to show how you would, configure variables within a module that you're consuming. So this small piece of code is now going to make sure that Vault is installed onto our Kubernetes cluster. And then we want to enable the transit secrets engine, right? So the transit secrets engine is the part of Vault that is responsible for cryptographic operations. So if you want to encrypt data, if you want to decrypt it, if you want to sign data, verify data, HMAC, whatever cryptographic operation you can think of, Vault will support it, and it's the transit secrets engine in this case that's going to take care of all of that for us. So we're just using the template resource here to develop to render, shall I say, a bash script, which is going to enable that transit secrets engine, because that's all we need to do to get us started, right? So we're just using this resource. We did this in a previous episode when it came to Nomad variables, and we're rendering it to a temporary destination here. And then what we do is we run a remote exec. Again, this is the same pattern we did with a Nomad when we were trying to get the variables into our cluster. So we're just using a Vault image for our remote exec. We're attaching it to the network, and we're saying, hey, run this command, which is basically going to run that script that we have rendered. And we're going to mount that script from the template here. And we need to set a couple of environment variables because it's going to run in a container. By default, what that container will do is it will try to run that script against localhost Vault, which is obviously not the Vault that we want to run it against, right? So we want to override that by setting the Vault adder environment variable, which we're just using some of the resource interpolation just to pass in that value. And we also need to give it the token so that it's authorized to do that. So yeah, essentially I've already run this script, and you can see here on my right, we have the transit secrets engine enabled, and it was all fine, right? You can even see here, this is the run where I deployed my development environment. Now, the last thing we have is we have this crypto.service resource, and all that is it's a container, right? It's a container, but instead of doing what we've done in the past, whereby we pass a container image detail, instead we don't have the image stanza, we have the build stanza, and the build stanza allows us to build from a Docker file that we have on our machine. So we don't actually have to have the image deployed somewhere and then pull it. We can actually actively work on it on our local machine, and we can use this to build our image and run it locally on our machine. So it's quite simple. We just have the Docker file, and the context is the location, the file location directory where it is. And then we just have some port mapping really. So the port mapping is just mapping it all to port 2000, and environment variable. We've set up an environment variable to name our service as crypto, right? So not to be confused with Bitcoin. It's actually for cryptographic operations, not for any cryptocurrency or mining or anything like that. So don't get any funny ideas. So let's get into this. We need to build a microservice, right? And that microservice is going to have to talk to Vault, and it's going to have to do a few things, right? So if I go to the README, I've actually written some of these operations down, right? So the first thing it needs to do is it needs to be able to, I'll zoom this a little bit. It needs to create the cryptographic keys, right? The idea is for each user that signs up, they are going to be given their own unique cryptographic key. And all of their data that is deemed personally identifiable or sensitive will be encrypted using their key, right? So we're not going to use one key to rule them all. It's just going to be one key per user. And the advantage of that is if we want to set individual policies for each user, like say a user wants to rotate their key on demand, or they want to automatically rotate their key every 30 days, for example, well, that can be done without affecting any other users. Secondly, if you think about things like the right to forget under GDPR laws, if someone says, well, I don't want you to have any of my data anymore, I want you to forget that I ever existed, the one way to be sure that we can do that is if all their data is encrypted with their key, well, we can just we'll delete their encryption key. And if we delete their encryption key, then nobody, including us, can access their data. And the thing about that is basically they have been forgotten. And we could just run like a batch job that looks through our database and tries to find data that cannot be decrypted, and it will automatically remove that, right? So it's just another way of doing things. So yeah, we want to create the keys. In order to do that, we need to give it a key name. We need to delete keys as well, the scenario I've just given you. We need to encrypt data, which we need to give it the key name we want to encrypt the data with and the actual data that we want to encrypt. And we want to do the opposite, want to decrypt data. So again, the key name, but this time, instead of giving it plain text, we're giving it ciphertext. And the other operation we want to support is rotate the keys. Now, I don't want to make this video too long, so we're probably not going to build all of these things out. We'll just build one or two just to kind of show you how this would work. And then we'll look at finishing it off and deploying it actually to a Kubernetes cluster and how we're going to manage this whole operation, right? So if we head over to our source code, I'll make this a little bit bigger. And we'll just head over to, I have some documentation here. I had a quick look at this before I started the video, but essentially the first thing we want to do is we want to create a client, right, for our microservice to use to connect to Vault, right? So if we do func and we're going to call it new client, okay? And basically in this new client, we're going to want to run this little piece of code here, right? And we'll have to refactor this a little bit to make it work, right? So we need to run that code there. But then the other thing is we actually going to want to return a client as well, right? Because this is the thing that's going to, every other operation is going to use this client, right? So when we call this function, we want to actually return a client. So if we just put in the return statement, I think it's going to be vault.client, right? And if we just add a return statement here, that will be return client. And what have I done here? I've done something wrong. We'll figure that out in a second. There you go. Just needed to do the pointer. The other thing I want to do is I want to just add Logrus. You can see we've got an error here because I haven't imported the log package, but I'm actually using Logrus for this. We'll actually improve the login a bit later on. But for now, I'm just going to go to our main.go, and I'm just going to copy this line here and just paste it into our Vault file. And this is how we're going to have Logrus. Right. So that's kind of sorted it, but like I said, we need to refactor this a little bit, right? Basically, we're going to need to specify the address, right? So in order to specify the address, we'll have that as an input for this function. So we'll call this variable, we're going to call it Vault adder, and the type of that variable is string, right? And what we'll do is we will remove this and we'll replace it with Vault adder, right? So that makes that a bit more usable, you know. It's not hard code. You don't want to hard code these things here. You want to be able to pass it in through things like environment variables and so on and so forth, right? Now, the only other thing I need to figure out about this is we need to actually set a token, which actually the code is right here. So we can actually just take this code here, copy it from our documentation and paste that here. And again, we've actually got a hard-coded token here, which again, we don't want to do that for numerous reasons. So we're going to add another input for our function, which is going to be Vault token. And that's also going to be of type string. And we'll replace this with Vault token, right? So that's the client that we're going to use every single time we run any operation that's going to interact with Vault. It's going to use this client with the address we specified and the token we specified in order to authenticate, communicate, and perform the operation, right? Awesome. So if we go to our main.go, we want to be able to pass this client in to our router, right? So if we look, I'll just zoom this up a little bit. We have router equals new router, and that's actually a mux router. And inside that, we're going to want to pass in a client. So what we'll do is we'll, just on a new line, we'll create a variable, which is VC. And that's going to go to new client. And we'll add those figs in just a second. But what we'll do is we're going to add this into here, which is probably going to complain because new router is a function and I haven't specified that as an input. So we'll sort that out in a second. So inside our new client, as you saw, we need to give it the Vault address and we need to give it the Vault token as well. So what we'll do is we're going to read that from environment variables, right? So we'll create a variable here, and that's going to be called also Vault adder. And we're going to use the OS package to read an environment variable, right? So we'll do os.getEnv, and the environment variable we're going to want to read, and we'll just use the standard Vault notation for this, just so that there's no difference. So it'll be Vault _ addr. So inside our client, we can then do Vault adder. And then we want to do a similar thing, and that will be Vault token, right? So if we do Vault token, And we'll optimize this a little bit. We need to do some error messaging for if these things are not set, then we want it to fail at startup so that, you know, we know something is wrong, right? So we'll do another one of these, and this time we need to get Vault underscore token. And in here, we'll just put Vault token, right? So that's cool. So every time our service starts up, it's going to read these environment variables. In fact, let's just optimize this right now. So if we'll do if vault adder equals empty string, which basically means the environment variable is not set. Then we'll do log dot fatal, and we'll just put in vault underscore adder has not been set, right? That's relatively straightforward to do. So we'll just copy and paste that line for the token as well. And just separate this out just to make it a little bit more readable. We'll do that, and we'll just change this variable here to token, and we'll just copy that and overwrite that, right? So basically now when the service starts up, if these environment variables are not set, then the service will fail. It will exit code 1 or something like that. And it's just easier to troubleshoot. You just want that fast feedback. I'd rather it does this than, you know, the service starts up and everything's fine until you try to run an operation and you're wondering to yourself, hey, why did that not work, right? So the other thing we need to fix is we have an error here. And basically that's because we are not taking Vault Client as a input into our new router function, right? So we can fix that. And that's in server. And we have this function here, which is what is basically calling. And I think it's going to be a pointer, and it's going to be vault client. I think it is. Let's see if that's right. It's probably still wrong. Let's have a look. See if we can figure this out. Use type vault client as it shouldn't have been a pointer, or yeah, it shouldn't have been a pointer. So that's my bad. So we'll just do this, and that should be fine. Bit weird, and I don't know why it's automatically done. Client there. We'll save that, and that has fixed our issue here. So now, every time it starts up, it's going to use that client for any interactions that it has with the Vault server, right? So we've got our client set up, and like I said, we're just going to create 1 or 2 of the capabilities that we need. So we'll head over to this file here, and we'll create a new function. And this function is going to be called create key, right? And I think we said before that we're going to want to give it, a key name. But how we're going to actually invoke this function here is, this is a microservice which is going to be called via, JSON HTTP. So essentially, if we look here, we have these routes, right? So this is like our default route, and basically we're going to want to return it as a handle func, right? So if we go back to our function that we just created, we want to return a HTTP handle func, right? Handle func. And what we'll do is we'll return, and it will be func And yeah, I don't like writing out all of that. So we'll just put W for writer and we'll put R for request. And that will satisfy that. And then we can write our actual logic inside of here, right? Amazing. So what do we need to do? We need to pass in the client into this, right? Because the client is going to have, we're going to have to use that to instantiate our calls to Vault, right? So we'll create a client, and that is going to be of type Vault client. I don't like that. I just want VC. Okay, and that means that inside here, if we do VC dot secrets, and the type of secret we want is transit. I'm just winging this part because I don't actually know exactly how this goes. This is one of the reasons why I love Golang, is because it helps me figure out some of these libraries, right? So I can see that we've got transit key create, and let's figure out what we need inside of here, right? So inside of here, we need a context. So the first thing we'll do is we'll set a context. So if we do CTX equals context dot background, and we'll pass in a context in there, CTX. So that's cool. And the next thing we need is we need name, right? So we're going to want to pass this this name. We'll just put some quotation marks there for now, just as a placeholder. And then we need something called request schema, right? I'm not sure exactly what that is. So I'm just going to create a variable and try to see what this type is. So it's schema.transit create key request. So let's have a look. So if I do, we'll do schema. Oh, can't spell schema. Let's give ourselves a, or we'll just do SCH equals schema. And I can't actually remember what it was now. Was it dot transit key create request? That was the one. And I'm not exactly sure what fields are inside here. So we've got all these fields. So we'll figure out what we're going to put as these values here. But inside this, we're going to just put in this variable that we've just created. That looks like it's going to be it. So let's figure out what we want to do, right? So allow plain text backup, I think we'll leave that as false. Auto rotation period, we'll leave that as false for now. We'll figure out what our strategy is as we're going forward. Context, I'm not actually sure what they mean by context. So we'll just head over to the documentation and see if we can get a read on what these things could mean. Let's have a look, right? See if it says anything about the context, because if not, we'll just leave it as default, right? Sometimes the API is better documentation for us to understand. So we'll just head over to this and see if we can get some more information. So for create key, this is what we're looking for. So in terms of the type, right? We're actually going to specify this because that's the default. I'm guessing if you don't specify it, will be that anyway, but we'll just hard code this just in case defaults change. And let's see, key size in bytes for the algorithm that allows, currently only applicable to HMAC, where it must be between 32 and 512. So we're going to leave that to 0 on hours. Again, we'll leave the auto rotation period the same. Managed key ID, name of the managed key, yeah, but we're not using a managed key, so we'll leave it as that. And yeah, that's it. There's nothing about context. Convergent encryption derived exportable, we definitely don't want it exportable. So we're going to leave all of those things as default, right? So with that, fingers crossed, we should be able to start to add a route to our router, which will call this function here, right? But we've forgotten something. We need to give the key a name, right? So if we do key name as a variable, and that's a string, so we'll pass that in, and we'll just change that to key name. And that should create a key for us, right? So let us add the root. So we'll go to our server, right? We basically want to copy and paste this line below it, and we'll refactor this line, right? Because these are our roots, right? So the root we're gonna have is create -key. And I think what we're going to want to do is we want to change that to a post. And the function that we want to call is create key, right? And inside that function there, we're going to want to, so maybe we do want to put VC here. We're going to want to put VC inside here. And why is that not liking it? Okay, and we're going to add, we need to give it the key name as well. So there's a couple of ways we can do this. We can do this as a query string parameter, which might make the most sense, to be honest with you. Or we can have it as a JSON payload and go through the whole process of, you know, unmarshalling it, whatever. I think because it's a single thing, doing it as a query string parameter is probably the way that we are going to go, right? So I can't actually remember how to do this. I've actually done it before in Mux in something else. So I'm just gonna have a quick look on my GitHub just to remind myself, right? So I'll just open a new tab, and we have, let's go with this. Actually, this is not the one. It's actually going to be in server.go, and we shall see how we did it. So how did we do it? So we add something like this to the end of it, right? So just have another look. So dot methods. Okay, so after methods, then we do dot queries, and inside there we're going to have key underscore name, and we just need to do this, right? So and that'll be key underscore name. We'll close that, and I think that's it. But how are we actually going to pass that in? That is the thing I need to figure out, right? So need to figure that one out. How are we going to pass that one in? Because we've done it as we need 2 inputs there. So maybe it is easier if we do it as it might be easier just to actually just unmarshal a payload. That might be it. That might be it. Okay, cool. Let's go back to this, right? And what we'll do is we are going to we're going to create a struct. Okay, so it's going to be type, and it's going to be key request. That's a struct. and it's going to be key name, and that's of type string, and we're going to want to unmarshal key name in JSON, right? So do that. And then inside here, there's probably more efficient ways to do this. I'm not the greatest Go developer, but hey, we're going to create a var, and it's going to be key name, and the type is key request, right? And get rid of this because we don't need that anymore. So that's fine. So cool. So now we need to decode a JSON request, right? So if we do error equals JSON, it should be new decoder, I think it is. New decoder. So we want to decode our JSON. And inside that, we're going to want to give it the request body, right? And inside that body is just going to be the key name, essentially in JSON format. And we want to decode that. Decode that, and we want to do that into key name, right? Cool. Right, so just want to handle that error now. So if error does not equal nil, then we're going to want to log dot error, right? And we'll pass in that. So that would just log that as an output. Amazing. And then what we do here is, instead of having this redundant thing, we do key name dot key name, right? That should be cool. That should be cool. So we're going to start thinking about testing this out, right? So at the moment, if I curl, let's just curl HTTP local host, just make sure that we're getting a response so far, and do that to port 2000. We get a response saying it's the crypto service. But what we actually want to do, and I hope this works, if not, we'll destroy our environment and rebuild it, is I am going to do a jump pad status just to get the resource ID, because we're going to want to taint this resource so that we can rebuild it. And the resource that we want to taint is, if I can see it, it's this one here. So resource.container.service_crypto, right? So we'll just save all of that. And then we'll do JP taint. And we'll do that. So that's tainted the resource. And then if we do JP up, that should rebuild our application. Fingers crossed, right? I didn't get any errors there. Matter of fact, to test it, it actually has rebuilt the application. I'm actually going to change something, right? I'm going to change, if we go to our container definition, I'm going to change that to service-crypto, service-crypto, save that, and then we'll just taint this again. And then run another JP up. And then if I curl localhost again, that should show service.crypto. So it's actually updated the application, right? So that's pretty good. So let's open up a Scratch file and let's prepare our API call to test to see whether this is actually working, right? So if I just go to new and we want a Scratch file, and we'll just do bash. Oh, it doesn't like bash, so it'd be shell script. And the command we're going to run is curl. Oh, here we go. This is nice. There's a lot of this auto population, which is dope, right? And we'll just copy and paste this into our endpoint. And yep. And it will be /create-key. If I remember correctly, I'll just double check that. I think that was the endpoint that we did. So yeah, it was create key. Yeah, so that's fine. Let's go back to our Scratch file. Let's create key. And then we want to give it, I don't know about all this -sl, that's not what we want. We want to give it a JSON payload, right? And that payload is going to look a little something like this, right? It's going to be key_name, and that's going to equal, we'll just put test for now, right? Test. And I don't think we need this output here, so we'll get rid of that. And I think that should be it. Fingers crossed. We shall see, right? What I actually want to do is just so that things are readable. We'll just do JQ, and hopefully, oh, you know what we didn't do? I've messed up. I apologize sincerely. We don't actually return a response code, right? So I'm gonna have to build this again. That's fine. So if we do w dot, oh no, I've got to do it inside the func. My bad. So if we do w dot write header, and the response code is going to be http.statusok, right? My bad indeed, right? So we'll just taint that. Oh, messing about. There we go, we'll taint that. Run JP up again. And the other thing we should have done actually is if we get this log, we should actually return an error here. So it should be internal server error. And that'll be a 500. Just do that. So if we get any issues decoding the payload that comes in, we should log the error and we should return a 500 response code. Otherwise, it should just return a 200. So that should be cool, right? Taint that, build it again, all good. And yeah, I think we are ready to test out our microservice, right? So if I just hit play on this, it should just run. Very literal. Oh, I think I've done something wrong. I'll just copy and paste this to command line myself and just see if it gives me the same shenanigans. I'll just open a new command line, and it's probably going to fail because I just remembered we haven't actually set the environment variables. Line 1. So what have I done? I've done something. It doesn't like something. What does it not like? I don't think it's that, but I'm just going to get rid of that. And still the same thing. We'll figure this out in a second, but I know that I've got an issue here because I need to set a couple more environment variables. So in here, I'm going to do Vault underscore adder, and that's going to equal HTTP local host, and that's going to be port 8200, and then we'll give it a Vault token, Vault underscore token, and that is going to be root. Right. So yeah, that's all good. Let's just format all this just to make it look nice and pretty, you know. Cool. Now we need to figure out what's wrong with our curl, because I've screwed something up somewhere, right? So normally the way I would do it is, let me just copy this. Or is it because I did that? Is that why? That doesn't like it. So, oh, clicked on the wrong thing, my bad. So normally the way I would do it is, I would do that. Let's just reconstruct this the way that I normally would do it, right? So it would be -x is post. We'll get rid of that. And then just do a new line, and then we'll do that. That's normally how I do it, right? And it's doing page not found. Interesting. Let's have another look and see what have we screwed up with our microservice. Did I forget to take out the queries maybe? If we go to server.go, I forgot to take out the queries. That's what the thing is, because we're no longer using this. So if we take that out, that should hopefully fix our issue. And we'll take that resource, JP up. Oh, because I'm in the wrong terminal, my bad. JP up. That should be good. And we'll go again. Where are we? Where's our scratch file? We'll just hit play on that. And it's still doing page not found, right? We will get to the bottom of this. Let's have another look at our root. Right, so we have a post method. Let's just make sure that is the root there. Okay, just copy that and make sure that I've actually done this correctly here. I think that's right. That's fine. I don't actually see what else the issue could be. Because if I just curl localhost and do it through port 2000, I do get a response there. So I'm screwing up something with my Mux router and I can't quite figure out what it is. I mean, it looks all good to me. That's the path there. We don't have any prefixes or anything specified, I don't believe. No, we do not. So, what in the world is going on? 404 page not found. I definitely hit save on this, did I? And I can't quite figure out what this is. We'll just copy that and just put it into our terminal directly, just so that we can just keep going up. Stop flopping between the files. We'll actually come out of this and we'll create a new terminal. I'm going to do this. 404 page not found. Localhost port 2000 What could this be, or what could it be? I am bare confused. And I only have 6 minutes before my next meeting, so I might have to pause this and come back to it after my meeting. We'll pause it, and then I'll come back after my meeting. Stay tuned.
2,000 years later.
All right. Meetings are done. We're back. I didn't want to bore you with all the troubleshooting, so I kind of just did a bit of troubleshooting, and I figured it out. So let me just walk you through what I had to change, right? So firstly, the reason why it was getting 404 page not found was basically I wasn't refreshing the container properly. So when I added the roots and everything like that, I didn't taint it properly and spin it back up. So as soon as I did a jump pad down, jump pad up again, then that part started working. So the lesson I learned there is if I don't want to have to do jump pad down and jump pad up all the time, I can just do jump pad taint, and it'll be the resource name, and yeah, then jump pad up again. It should refresh the container, right? The other thing is I actually went to a model where I was actually building the container manually. I actually might switch it out in my jump pad code, but I started building it with Docker and basically running that image that I built rather than using a build stanza within there. I just needed a bit of faster feedback just to figure out if it was something with my Docker build that was broken or not. It turns out there was something wrong with my Docker build at the time, and that was, if I show you the Docker file, I had to update my Docker file. I'll just zoom this up a little bit. It was using the 1.17 Golang image, but in my Go mod file, it was requiring 1.18. So as soon as I update that, that solved that problem. And then I ran into another problem, which I will just show you. If we go to our Vault function, here, this code that is grayed out, I've commented it out, is basically how I was trying to create the key. But every time I ran this, I made an API call to it, I was getting a nil pointer dereference, and I couldn't quite figure out what that was, right? So I decided to go another route. With our client, we can actually do raw calls to Vault. So here, if you look at what I have done instead, is I used the Vault client, and it has like a write function inside it. So you just give it the context, you give it the path you want to write to, and if there's a body that you need to append to your request, you can put a body there. Obviously, I don't need a body for this specific one. And then the path, I just literally just put in the Vault path, which is transit/keys, and it's / whatever the key name is, right? And we just grab that from the JSON payload. And that's pretty much it. So if we have a look here in our Vault, you can see when I run the command, I've got a key called test. Let's run that again. But this time, what we'll do is we will change it to, instead of the key name being test, we're going to change it to Rob Barnes, right? And we'll run that. And if I come out of this and go back into it, we'll see I should have another key, which is Rob Barnes. And now we can encrypt data and we can decrypt data with it. So that is pretty sweet. So, you know, the video's been going on long enough. What I'm going to do is I'm going to write out the rest of the functions that we need, right? So we talked about creating keys, deleting keys, encrypting data, decrypting data, and rotating keys, right? I'm going to build out the rest of those functions, and then we're going to come back in the next episode and we'll walk through those functions, what I've built, and then we'll look at deploying this to Kubernetes and using the whole Vault sidecar injector piece to get information, well, firstly to authenticate to Vault, because we're not going to give it a root token. So we're going to use the sidecar injector to maintain that token. And essentially we'll use that to interact with Vault to encrypt and decrypt our data. So yeah, that's been it. It's been a lot of fun, a lot of headache, but we made it. Until next time, people, peace.